In this video, we'll be solving the system of equations displayed. We can begin by making y the subject for the first equation by subtracting yx squared. And now factoring out the y, we have that y is equal to 2x over 1 minus x squared. We can do the same thing for the second equation, making c the subject. And the same thing for the third equation. Okay, so note here the form these equations are in, 2x over 1 minus x squared. And what you might notice here is that it looks similar to the tan double angle identity. So because we know that x, y, and c are all real number, and because the range of tan is the real numbers, so tan theta can be any real number, we can let x to be equal to tan A, y to be tan B, and c to be tan C, because we know there must be an angle ABC which equals x, y, z respectively. So substituting that in, and now once again from the tan double angle identity, we have that tan B equals tan 2A, tan C equals tan 2B, and tan A equals tan 2C. Okay, so how do we proceed from here? Well, note that tan B appears on the first equation, but it also appears on the second equation. And well, if we can manipulate tan B to become tan 2B, we can write tan C on the first equation. But also note that tan C appears on the third equation as tan 2C. So if we're able to manipulate tan C to be tan 2C, we can write tan A on the first equation. So that means that we will have tan A equals tan something of A, which we can solve. So how do we do this? Well, from the first equation, we have tan B equals tan 2A. And now, if we want to find tan 2B, we can apply the tangent double angle identity again. But from the first equation, we can substitute tan 2A in. And now simplifying will give that tan 2B equals tan 4A. So if we know that tan of an angle equals tan of another angle, doubling one angle will mean that it will be equal to tan of double the other angle. And we will be using this fact more and more. So now we have that tan C equals tan 4A from the second equation. But using the same idea, we have that tan 2C equals tan 8A. But tan 2C is equal to tan A. So we have that tan A is equal to tan 8A. Okay, and well, it might be tempting to just remove the tan here and have A equals 8A. But note that tan is periodic with period pi. That is, we must say that A plus pi k equals 8A. And by making A the subject, we have that A equals pi k over 7. So substituting that into the x equals tan A, we have that x equals tan pi k over 7. And now for y, we can substitute x back in there, and applying the double angle identity there again, we have that y equals tan 2 pi k over 7. And doing the same thing for c gives 4 pi k over 7, and the tan of that. And if we want to check that we have done nothing wrong, we can do it for x again. And what we will be getting is 8 pi k over 7, which is just pi k over 7, because 8 pi k over 7 minus pi is pi k over 7. So there's no contradiction there.